Hello, Dr. Jones. This is my submission for the project number 2, create an insect project. So for this project, I named my insect the Texas bowl bleeder. This is just a picture of it here. For the anatomical structures, I labeled the clavate antenna, compound eye. It has an elytra, an ovipositor at the bottom, cursorial legs, and mandibulate mouth parts. For this insect, I chose the crop that it primarily feeds on as cotton. It damages crop via mandibulate mouth parts that tear up the leaves of cotton plants as well as the cotton bolls themselves, leading to plant reproductive harm as well as total plant death. I included a picture of the leaf damage, and you can see on it the skeletonization. And then on the cotton bolls, it shows a large hole in the center, and then because it's bored into that cotton boll, it's caused rotting on the outside, and that's the brown. For development, it goes through the egg stage, larval with 3 or 4 inch stars, pupa, and then finally it ends in adult. The GDD formula I used was the traditional high degrees Fahrenheit plus low degrees divided by 2, and then subtracted my base temperature. For my base, or my lower temperature, I chose 55 degrees. Just through research, I found that this was typical for many beetle species. I'll also mention that the insect order for this is determined to be Coleoptera, mostly due to the antenna as well as the cursorial legs, which are used in a lot of Coleoptera breeds, or species, excuse me. So I chose my lower base temp as 55 degrees Fahrenheit. My upper was 95 degrees. I found that through research, this was a temperature that most insect orders begin to slow down in development due to high heat. Then this is my weather table. I just chose some average temperatures and then used my formula for GDD with a base of 55 degrees. It ended up being a total GDD of 116.5. For economic level, I chose my EIL to be 8 larvae per 100 bolls, which at first it doesn't seem like a lot, but each cotton plant has about 20 bolls on it, so this actually comes out to quite a bit of loss of 4 to 5% yield loss. And then I just calculated this as about a $35 per acre control cost. For the ET, I chose to do slightly less, 5 larvae per 100 bolls. This is mostly because, as we talked about in lecture, we need a little bit of gap between EIL and ET to allow for whatever control method you choose to start taking effect. And also because these cotton bolls, a lot of the time the insect will be inside of it, and it'll be hard for that chemical to actually reach the desired pest. Next, I graphed it. I included EIL at 8 larvae per boll, per 100 bolls, and then the EL slightly below that, like we discussed. Then you can see as GDD increases, the overall pest count increases. This insect I chose for the most damage to occur during the larval stage. So you can see pretty much immediately after the egg hatches, there's a sharp incline of slope on the line of pest count, and then once it goes through metamorphosis and goes through pupation, when it comes out as an adult, it won't have as much effect on the plant. And then I included here just best trap for this insect would be a pheromone trap. So I just drew a picture of one hanging up in a yard. Thank you for watching.